So NASA is getting ready to launch a new mission to Mars, and here to talk a little bit more about the mission and also, what they're hoping to learn about Mars and maybe what its atmosphere looked like several billion years ago, is Dr. Jim Garvin, who is going to tell us a little bit more about this. Thanks so much for joining us.
It's my pleasure.
So tell us, when did Mars have weather like Earth, and what did it look like?
Well, a long time ago, we think billions of years ago, perhaps as long ago as 4 billion years ago, Mars had a climate state with a bigger atmosphere that supported surface water, rain, rivers, perhaps shallow seas, persistent surface water. Unlike the desert of today, that allowed for a situation for the chemistry associated with that to be recorded in the rocks. But that state of Mars is long gone. We don't see that today from any of the voyages we've made to Mars with our robots since the 60s. So something went wrong. Something went awry. Mars behaved differently. Figuring that out is central to understanding whether Mars could ever have preserved the record of past life.
So tell us a little bit about this new Mars mission and what kind of science it'll collect.
So our next mission to Mars is called MAVEN. It's all about interrogating the forensic science of the Mars atmosphere in reconnaissance mode, measuring not only the atmosphere that we see today, but using that atmosphere and its interaction with the particles and fields streaming off the sun to understand how it got to be in that state. What possible pathways did the Mars we see today, that we can measure from MAVEN, got it to this state relative to that Mars of the past, the warm, wet, cloudy, rainy, river-filled Mars that we've been seeing at the rock record level with Curiosity? What did that? MAVEN's all about making that connection, connecting the dots from the atmosphere down to the rocks.
So tell us, why is it so important to understand what happened to Mars's atmosphere?
Because Mars' atmosphere is a critical element in asking whether Mars ever could have been alive. The atmosphere is part of the environment that allows conditions that we call those that are habitable, habitability to persist. We see in the past, recorded in minerals and rocks and other things, that Mars had all the right stuff, the right conditions, chemicals, presence of water, energy systems to potentially have sustained the kind of life that we know on Earth. But now it doesn't. The atmosphere is a record book. It's a time capsule and a chemistry lab for how Mars works today and how it got to be the way it is today. We need to see that atmosphere up close as it interacts with the solar wind now, the sun, and with space weather, and how it might be evolving. What's it losing to space? What chemical reactions are ongoing? What species that we can't really see easily are there? How do those link back in time to that better Mars state?
So does this mean there could have been life on Mars at one point?
We don't know whether there was life on Mars, but we know the kind of questions to look for to read the records of what might have been, the so-called preservation potential of what we would call signs of life, biosignatures. They're recorded in rocks and chemicals, even in atmospheres. We know some of the kinds of things to look for, but we need a better picture of the whole atmosphere system, the rock system, even the interior of Mars, to be most informed on how to ask that question. Because Mars is the first good place to ask, are we alone, at least in the past, with respect to things like life. So we got to be smart about asking. It's a big place. It's a big atmosphere, even for a small planet. And that's why Mars is so cool.